Okay, so the other triangle that you have to memorize is the 45, 45, 90 triangle. So let me start out with a square. And we know that each angle is a 90-degree angle, right? And I always like for my hypotenuse to be 1. So I'm going to draw a diagonal with length 1. Okay, and since I'm bisecting these corner angles here, each one of those is 45 degrees. So what I'm going to do is I'm going to redraw that 45, 45, 90 triangle over here, and then we will go through and figure out what the lengths of the sides are. Okay. Now, there's a lot of math that's going to go on here. One thing that I want to review quickly is rationalizing a denominator. So if you have 1 over the square root of 2, right, and you want to get rid of the square root of 2 in your denominator, you have to multiply by the equivalent of 1. So same thing on the top and the bottom, and we know that to get the square root of 2 out of the house, we have to multiply by the square root of 2. And so we multiply 1 over the square root of 2 by the square root of 2 over the square root of 2. And we multiply our fractions across, and we get the square root of 2 all over 2. Alright, keep that in the back of your mind. Okay, so we have a right triangle, and it's actually an isosceles right triangle, right? Because the base angles are the same, meaning that our side A and our side B are the same, right? So if we start with our Pythagorean theorem, we have that a squared plus b squared equals c squared, which in this case is 1. Well, we also know that a and b are the same, so I would have a squared plus a squared is 1, which means that I have 2a squared, which is 1. Now, if I divide both sides by 2, I get that a squared is 1/2, right? And now if I square root both sides, I end up with, I'll just draw a line here, a is equal to 1 over the square root of 2. But we know from before, right, that when we have a radical in the denominator, we have to rationalize it to get rid of it. So that means that a is equal to the square root of 2 over 2. And so let me scroll down a little bit here. So if I have a 45, 45, 90 triangle. Let me recap for you. My hypotenuse is 1, and so that means that my other two legs are the square root of 2 over 2. And the reason why this is nice is because what I really want to know, and I should have done this in the other video, but I didn't, I guess I could go back and do that. I have sine of 45, and remember that sine of 45 is opposite over hypotenuse. Well, it's the square root of 2 over 2 all over 1, right? And if we have 1 in our denominator, we can kind of ignore it, but sine of 45 is the square root of 2 over 2. Similarly, the cosine of 45 degrees, right, that is adjacent, over hypotenuse, that's also the square root of 2 over 2 all over 1, which is the square root of 2 over 2. Similarly, tangent of 45, right, that's opposite over adjacent. We have square root of 2 over 2 all over the square root of 2 over 2. And one thing divided by ourselves is just 1. So tangent of 45 degrees is 1. So that's why I want you to memorize these triangles and the SOHCAHTOA, because from there you can get a lot of values, right? So you should actually be able to go back and draw out that 30, 60, 90 triangle and find sine of 30 degrees, find cosine of 30 degrees, tangent of 30 degrees, sine of 60 degrees, cosine of 60 degrees, and tangent of 60 degrees. And go ahead and do that and bring that in on Monday at the beginning of class for some extra credit.